right, today's another great day for coding challenges. Let's get back to it in the 7 Caillou series. We have one called nice array. A nice array is defined to be an array where for every value n in the array, there is also an element n-1 or n+1 in the array. For example, consider an array with 2, 10, 9, and 3. That's considered nice because the 2 has a neighbor with the 3 value here. It's only 1 away. 10 has a neighbor in 9. 9 has a neighbor in 10. And 3 has a neighbor in 2. There's only a difference of 1 between those, and it can be either higher or lower. It doesn't matter. Write a function named isNice that returns true if its array argument is a nice array, otherwise false. You should also return false if input array has no elements. Okay. So, you know what to do. Now is your chance to shine. Pause the video, crank it out, and come on back. I will go over 2 ways to do this. I'm going to kind of do what we call the naive way, just using basic building blocks. We'll solve it, and then I'll do a nice short one using link methods. So enough of this not implemented exception. That's a nice placeholder while you're working. Nice reminder when you sometimes need it, but we don't need that now. So my strategy will be, you can imagine we're going to iterate over this array. We're going to have to scan all the elements. So for starters, I'm just going to set up that loop for us. Int I equals 0. We know arrays have a length property that tell us how long they are. There we go. Okay, so I'm going to go through this. And before I actually code, let me talk about how I'm going to think about this problem here for this first solution. I'm going to start from the left, and I'm going to grab elements, and then I'm going to note what the element is. Then I'm going to sort of scan the remaining part of the array, checking for that neighbor in this part. So I'm actually going to have an inner loop that'll take off one index after the one I'm examining. And as soon as I find a neighbor, I'm going to consider this index under evaluation as satisfied. It's complete. It has a neighbor. And then I'll proceed to the next value, which would be 10 here. And then for 10, I'm going to scan the remainder of the array for a neighbor. In this case, it does have one. And I'll proceed that way. Then I'll get to 9. Now the catch is I'm going to store the indices that I've found have a match. So consider back when I was on 2, I would have eventually made it to the end of the array and found 3. And I'm going to make a collection that holds the 3. And so I'll be able to check against that. So by the time I get to the end, you can imagine I'm examining 3. There's no remaining part of the array, right? And then I don't have to go backwards and reprocess numbers that I already did. It kind of takes advantage of work that I've already done, if that makes sense. So let's see, what could that look like? Well, for starters, let's make a Boolean flag here, and I'll just say match. And we're gonna assume for the time being that there is no match. And then I'm gonna get that inner loop going. I'm just gonna use J for my inner loop variable name. And we're gonna start at I plus 1. And then J is less than array.length. We still don't wanna overrun the array. So you can see this inner loop now. It's basically starting 1 after whichever I value you're working with, and then it's going to go the rest of the array. Kind of like what I described. Okay, so now we need to scan the values here and see if they're within 1 of whatever array value we're looking at here. So I think it'll make more sense when I write some code. So we can say if if the array at index j is equal to i's value plus 1, right? We're going to have two conditions because we're checking if it's one higher or one lower. And then we'll use a logical OR here, right? Array j equals array I minus 1, because either one's okay, right? It can be one higher or one lower. In that case, we know we found a match, right? So I can say match is true. We verified that. I mentioned that we're going to sort of note the j index in this case. We're going to save it, so as I get later on in the array, I don't have to reprocess values that have already been processed. So let's make a collection for doing that. Okay. I'm going to use a collection called a hash set, and I'm just thinking of it like a set. A set is a collection where values aren't repeated. And then the hash part has to do with accessing the data. We'll learn more about dictionaries and hash set collections. So hash set, I'll call it match indices equals new hash set of int. There we go. Now we've set it up so we're ready to actually use it. So you can check the docs page on hash set. It'd be good to read about to get an idea of how they work. It's right here. Just Google hash set there. And they had a nice description if you scroll down to this part in the remarks. This is a nice part, provides high performance set operations similar to accessing the keys of a dictionary. I like this part. In simple terms, the hash set class can be thought of as a dictionary collection without values. So it's almost like the key is the value. That's a nice way to think of it if you're familiar with dictionaries. But don't worry if you're not. It's just think of it in terms of a set where we don't have duplicate elements, as noted. If you don't need duplicates, you don't have to worry about it. So yeah, we've got that match indices, and we're going to want to add that to our collection J, and then we won't have to process that again. And because we have this match indices now, we can possibly save ourselves some work here before we even get into searching. We can say if match indices contains I, then simply continue. And the continue, of course, will just not process anything else in the scope of the for loop. You can think of it as ending here, kind of like a return does with a function, but continue works with looping structures, so it will just go to the next value. So if I get here and this is true, I say continue. Let's say I was 0, then it just starts back up at the top again and bumps I up to 1 because I told it to increment by 1 every time. If we were on 2, index I equals 2, hit this, then it wouldn't execute any of this logic, goes right back to the top and bumps it to 3. So hopefully that's clear. So good, yeah, we don't have to process things we've already processed. Good. And yeah, when we find these matches, we're sure to add index J because eventually we're going to hit it. And then here I'm saying we can break out of the loop at this point. And break is similar to continue in that if there were statements down here, more code to run down here, it would never reach it. Once it hits break, it breaks out of the immediately enclosing looping structure. So it's this inner for loop. It's saying break out of that. It doesn't matter what index you're on, you could be nowhere close to the end of the array it says this whole for loop is done. Get out of it. So that basically drops us back out into the scope of the outer for loop. That's what break does. So we'll get rid of that gibberish. Because think of it, if I'm at 10 and I find a neighbor, you know, in the next index, do I need to keep going and look at 3 and imagine if there's 100 more values here? No, we already know it has a neighbor. It doesn't matter if it has 1 neighbor or 20 neighbors. We got the one, we know it's a match, so stop processing. Okay, so we should be good there. And then the key is we've set this match flag. So what we want to do is after we've processed the inner for loop, when we check the rest of the array for a match, there better have been one, right? Because if there's even one element in the array that doesn't have a neighbor, we know the whole array is sort of ruined, right? It's going to return false. It's only nice if every element has a neighbor. So we can check if not match, that's the same as saying if match equals false, then you can simply return false. Just end the whole processing, right? If this first value 2 didn't have a neighbor, there's no point in checking the rest, because even if 1,000 other elements do have neighbors, that one at the beginning does not, and the whole array is considered not nice. So we can say return false. And then finally, provided we got through all the values and they did all have neighbors, we would have survived and got outside both for loops, and we can simply return true. And so I think that covers us. We can go ahead and run some tests to be sure. I think I'm going to get an error over the hash set. I'm going to have to bring in collections using system collections generic, right? And then we can use a lot of these collections. Okay, let's run it. Make sure I see if this works. Okay, the name match. Oh, yep, I see it. Do you see it? Spelling matters. Eneidsis. What's eneidsis? Where did I do that? Indices, probably down here. Yeah. Good catch. Okay, cool. Yeah, green looks good. So yeah, that's sort of one way to do it. We can do the link way now, but this is just something if you don't know the link methods, or, you know, the nice thing is the link methods aren't always the most efficient thing either. Sometimes it's better to write your own code because you can do some of the optimizations like we did and make sure you're not processing elements more than once that don't need to be. So yeah, we'll go ahead and go into a link solution now. So I'll go ahead and comment everything out. Remember, for multi-line comments, you got the /*. So we're all commented out here. Okay. Let's do this for the Wally one-liners out there. So how can we do this? Well, I'm going to scan the array, right? And before we even get too involved, let's bring in system link, so we know we'll get yelled at if we don't. Array, and do you remember where? I like to think of that as the filter, array where. So this will go through each element in array and apply some conditional check to it, right? And we've got to provide that. What are we checking for? Well, we want to see if each element has a neighbor, basically. So I like to name, we're going to use a lambda expression for that. Remember, the first part is your parameter list. It's just like an anonymous function. It saves you the trouble of writing out a whole separate function. So the first part's your parameter name. For integers, I like to use n. It's pretty well accepted. And then I'm going to check if array contains n-1. We've seen contains before. or array contains n plus 1, right? Neighbors can be on either side. Okay, and we're doing that for each n. And then finally, that's going to return a collection, right? If I just have this filter on, it's going to go through the elements. For each element where it has a neighbor, it's going to produce a new collection with the values that have neighbors. The ones that don't have neighbors will be omitted. So what I can do then is make sure that the size of this new collection being returned by where is the same size as the original array, which is another way of saying that they all have neighbors. So you can check the size by using this count method. So that gives us the number of neighbors. And then finally, we want to make sure that's equal to the original array size. If it is, that means that's the same as saying everybody has a neighbor. So let's go through this. Good, green again. So yeah, there's a nice, this is probably a lot nicer to look at, right? You'd agree. Pretty expressive. You get the idea across in one line as opposed to having all this. Now, you could run performance checks on these. Like I said, a lot of people don't like LINQ because it's not always the most efficient thing. You know, look at, I'm running 2 contains checks here, and you can imagine these contains are scanning the whole array. So how many times I'm already going through the whole array once because I got to look at every element in here. And then for each element, I'm going through the array again for an n minus 1, doing it possibly again for an n plus 1. So I mean, how many times are you scanning an array? I was trying to cut that short when I made my own method here. The idea with these hash sets is with hashing that you can access elements very quickly. What it does is basically will map your key to an integer value, and that probably sounds bad here because we're dealing with integers, but you can imagine hashing with strings, with custom object, you know, from the classes you make. It'll generate an index value, and we know with arrays you can access data very quickly by an index value, and so they can leverage that power, and so you don't have to look through each element to find something. When you're searching for something, you don't have to start at the beginning and keep looking at each element until you find what you're looking for. With a hash set, you can get right there. So I was trying to take advantage of that. Did some things to break the loops early where I can. So I don't know how these would compare. You would want to have a huge array if you wanted to test that, make it with many elements, thousands, and then time them. You know, you could check it out if you wanted. I'm not going to do that here, but I just wanted to issue that warning that LINQ isn't a end-all. It's not always the most efficient thing. In a lot of times it doesn't have to be. You know, it depends on your application. Maybe it's not critical. You know, in general, though, people like code that runs faster. So yeah, I'll go ahead and submit this version. I'll delete the other one, although I suppose it doesn't hurt anything. Let's get those hard-earned kata points, honor points as they call them, I think. But first we got to hit the large attempt too. See, yeah, you don't want to claim victory yet. So what did we do wrong? Expected true, but was false. So let's do a little work here. One thing I want to add, private So it'll help us do a little analysis, because obviously this expected false but was true. That's not helpful at all, right? I have no idea what they're talking about. So let's help ourselves. Int n in array console write I'm going to write the value in a space, and I'll say console write line. Okay, now let's print our input to see where we run into trouble. Green, okay. Oh yeah, we know the test one was green. So here we go. Log. Oh sure. So it seems to have choked out here. And remember, they warned us in the instructions, right, that you should also return false if input array has no elements. So yeah, let's go ahead and handle that edge case. If array length equals 0, we'll just say return false. That should cover us there. I'm gonna get rid of the print statement there. Let's try that attempt. Okay, now we're good. Yeah, I probably should have handled that edge case up front, but no worries. I'll get rid of the print statement. But that's what I was trying to tell you about in some other videos. If you get stuck, just, you know, you got to print some information out to help yourself so you can debug things. Finally, clean up before we submit, just like in real life too, right? You're working, but you're about to commit some code. You want to make sure you get all of your, you know, your scratch work out, stuff that doesn't need to be there. I'll get rid of all the noise, refactor the methods, you know, if appropriate. So I'll go ahead and submit this now, finally. Okay. And then, yeah, as usual, look through what they're doing here. There you go, any and all. You know, maybe you haven't seen those before. Check those out. That seems to be pretty popular. But yeah, let me know if you have questions. We'll get more into the various data collections, hashing and stuff like that. We can do that in later videos. I wasn't sure how deep to go into that here. But anyways, as usual, thanks for watching. Thanks for all the people who give likes and who subscribe. I really appreciate that.